Okay, here's the recap on yesterday's mechanical gears lab that we didn't finish. Not sure why. We just didn't finish that lab or the talk. So we get an introduction, read through this here carefully about where gears are used. You probably see gears or use gears constantly, may not even know it. Again, many of you have built this system here. I have more parts I'll have in these bins for you guys to use, but if you don't, you have to improvise, like use different parts to get the same basic setup. Okay. Here's some of the gears we have. Again, a 12 tooth, 36 tooth, they're all here. And that's important to know for our gear ratios in a little bit coming up. But make sure you know that the driver gear, when the handle attaches to, it does the turning. This is the powered gear. The driven kind of gets a free ride. This guy does the work, they get the free ride. Gear ratios are important, and you always want to make sure you know that it's always like a how many does each person get. Let's say you order up like 15 large pizzas, and there's 30 people at a gathering. So 15 pizzas for 30 people. Well, how much is each person going to get? If you do the ratio, 15 pizzas, 30 people, that's about half a pizza per person. What's a pizza ratio? All right. Or if you're making some kind of recipe, how much does each, how much per ingredient? Maybe you're making some cookies, and it calls for 2 cups of sugar. Well, 2 cups per batch. If you're going to double the batch, you have 2 cups per batch. So of course you double things up. But now for our gear ratios, it's a division problem. It's a number of teeth on the driven gear divided by number of teeth on the driver gear. Driven gear divided by driver gear. And if our system, let's say, quick visual, if I turn the handle on my gear one time around, and my driven gear, let's go over here once, turn the handle 1 revolution. I want to know how many spins this wheel here is going to get. Is it more than 1, less than 1, or exactly 1? What's it going to be? A more than, a less than, or equal to? I have to figure that out. Here it says if my speed of my wheels increase, maybe 1 handle spin or 1 driver spin gives me, say, 3 or 4 or 5 driven spins, I'm gaining speed. I'm actually going faster. Some of your bikes have the sprocket set up where I can pedal and go pretty fast. If I change my sprocket configuration on my bike, I can have it where I go slower. Maybe it takes 7 or 8 handle spins or pedal spins to get just 1 wheel spin. So 7 or 8 pedal cranks, I get 1 tire rotation. Here I'm going to have a lot more power, a lot more torque. Torque is a twisting, turning force. So you're going to have a high speed system or a high torque system. Okay, so read carefully. Then you would build this lab, build both gears, as the picture shows. If you can't see so well, it says click here. This brings me to a better view. I gotta build it as the picture shows. So I have the bushings, they're bolted on. I got bushings on the back side, front side, axle goes through, I have a collar, I have the handle on it. It's all right here. Okay? So I'm gonna build that system like it shows. So I read the packet, step 1, build the lab, step 2, test it out, step 3, answer these questions, that's step 4. It says here, what's the relationship of the driver gear axle to the driven gear axle? So it's asking us, if I look at this axle and this axle, these here are going to be, what's that math word? 2 lines don't intersect. That's what it's going to be. Okay, so go back. Back. There it is. 1 says, in gear train A, does the driven gear speed increase, decrease, remain constant? That's a gear ratio problem. Here I have these two gears. I have a 60 tooth and a 60 tooth. I have a 60 tooth driven, 60 tooth driver. I plug it in my formula. 60 divided by 60 gives me 1. So I have 1 handle spin to 1 wheel spin. You're solving a ratio. How many spins to how many spins? Nope. Get out of there. Alright. So that's my challenge. So I want to go handle spins to wheel spins. In this case, driven divided by driver. So if I have a 60 by 60, it's a 1 to 1 system. See, I always word it as how many per person for the pizza problem, or how many cups per batch. It's always how many per 1. How many per 1. So here I have 60 divided by 60. My answer is 1. So I word it 1 per 1. Always per 1. Okay? So this is a 1 to 1 system. I'm going to be number 2. It says build the gear train B, but I have no photo. Here's photo for A. I have no photo for B. Alright? A 36 tooth driver gear, 84 teeth driven gear. And it says, asks about the gears. Is it an increase, decrease, and same? Again, I take my formula. I have an 84 driven, so 84 divided by 36. You find that answer. Okay? So that's going to be, it's going to be that answer per 1. So an 84 36 per 1. Let's solve it. Divide them out. This divided by that. Figure out the answer. Then, as far as torque increased, decreased, constant, what does that mean? Well, in A, if I'm gaining no speed, I'm constant, I'm going to gain no torque. I'm constant. In gear train B, if I am increasing speed, I'm going to decrease torque. They're opposites. If I gain in speed, I lose torque. If I lose speed, I gain torque. Okay, like a teeter-totter. If you take a picture of a teeter-totter, and on one end of my little teeter-totter beam, it's sitting speed, other end is sitting torque. If torque drops, speed has to go up. If speed drops, torque has to go up. They're opposites. If you have a torque system, you have low speed. If you have a speed system, you have low torque. They're opposites. So answer 4, the same way. I'd solve, here's my gear ratio, solve gear ratio for A, solve gear ratio for B. I mean, you did it already up here. You solved it. The answer goes down here. 7 means, is the power of flow reversible? Meaning, can you make the gear drive turn by turning the driven gear? If I take the handle off the drive gear, plug in a driven gear, if I turn it, will it turn? If it's yes, then it is. If no, then it won't. And then figure out number 8, and then do number 9. Then what's next? You find your sign-off sheet, wherever it is. That's not it. That's not it. There it is. And you would take this simple gear one. When A is done, we get A signed off. When B is done, we get B signed off. Score yourself based on the rubric up here. Where you at? A 5, 4, 3, 2, 1. And then have the teacher sign off here. Okay? Then you go on to simple gear with idler. Where's that at? That is over here. There it is. Alright? So it says here to build this gear system, wants to know the axles. That's the same for letter for the first one. And then go on 2 and 3. 4 says to reconfigure it. So you build a different one. But this tooth driver gear, this tooth idler gear, this tooth driven gear. Here's my handle. Here's a driver. Here is the driven. This is the idler gear, the one in the middle. Driver, driven, idler. Okay, so good luck with this assignment. I hope it helps a little bit. If not, rewind the video and play it again.